Welcome to Pure Math 030. This is an exercise on solving quadratic equations graphically. So previously we looked at solving them using the quadratic formula, which works great. It works for every quadratic and it gives us exact values. However, we can solve these graphically, and by graphically I mean using our graphing calculator. And it all comes down to this. The solutions of any quadratic equation set to 0, the solutions will be the x-intercepts of the related quadratic function y is equal to ax squared plus bx plus c. You will remember that x-intercepts are found by setting y is equal to 0. So all you do is take that quadratic, replace y with 0, and whatever you get for your x-intercepts become your solutions. Now that can be done on paper, of course, by replacing y with 0. But on the calculator, we will use the features that functions that allow us to let the calculator do it for us, basically. And I'm going to go through one question, and I will bring up the calculator to show everybody how we do this. You'll note that I am asking you to solve this correct to the nearest tenth, and that's okay, but it does expose a limitation of the graphical method. We cannot get exact values unless they work out to be whole numbers or fractional numbers we can deal with. So if you do need exact values, you have to use the quadratic formula. And more on that later. So here's our equation, 3x squared plus 11x minus 4, and I will bring up the calculator. So, turn the calculator on. Y equal 3x squared minus 11x. It's actually supposed to be plus 11x. So I'll replace that. Move the cursors over, and then minus 4, and then graph. Now I would like to see the bottom of this graph even though I don't need it. So I'm going to change the window settings manually. I'm just going to change that y minimum to negative 20. Not necessary, but it will allow me to see, I think, the bottom of that graph. Not even. Okay, I'm not going to go any further with that. The vertex is lower. I'm not asked for the domain and range, so it doesn't really matter. Now to get the x-intercepts, there's two of them, and I'm going to get the one on the left. So I press second trace, which is the calculate menu, and then I press 2, which is the 0 key. And it's very similar to the previous max-min function that we looked at. We move the arrow to so it's to the left of what we're looking for. So it doesn't matter where, but it has to be to the left of the x-intercept, and then press enter, and now we move the arrows over to the other side. So that's good enough. You see where it is now. I press enter. I move the arrow back to somewhere between the left and the right boundary and press enter, and this is my guess. And I get 0, x is equal to negative 4. Now, you'll notice the y value should be 0. What they have is negative 2 to the times 10 to the negative 12, very close to 0. That will happen. But the x equal negative 4 is our solution, or our 0. Then I want to get the other one, so I press second, calculate again, and to 2. And I move my left boundary. This time going after the other one, so I want to bring it to the anywhere there. Now that's adequate. It's to the left of the intercept, and I press enter, and then press enter to bring it to the right for the right boundary. Once again, I guess. Press enter, and I get 0.3333. Now that is actually to the nearest tenth would be 0.3. Just as the previous one would have been 4.0. And that's good. We now have our two intercepts. And the big idea is that this could be used to solve any equation. It doesn't matter if it's quadratic, linear, trigonometric, logarithmic, you can always use your calculator to get them. So what people generally do is once their algebra breaks down, or they've gone as far as they can algebraically, then they rely on using the calculator to get the answer. In the 30 pure, it's a big thing. You will actually get questions that can only be solved using the calculator. So you really want to train yourself to do this. So that takes care of that exercise. In fact, that is the last of the review material. Thank you for your time.